All right, we're back again with example 1. So I want to show it to you 2 times. First, I'll show you without the calculator, although we really do need it for the approximations. And then I will show you how to do this whole process with just the graphing calculator. And on your unit assessment, you guys will be allowed to use the calculator. So you want to practice it with the calculator method. It's actually really easy to do. So example 1 here, using Newton's method, they've given you a function. Now this one's kind of silly because it is a quadratic and you could easily find your zeros just using other methods like factoring. However, let's take our process here for a spin, and then we can also have a good way to check our work, right? So they've given us our function, and they've also given us x1, our initial point that we're going to use as an estimate of what our zero should be. So let's go ahead and just rewrite our formula. So x sub n plus 1, if I want to calculate the next estimate, I can do that by taking the previous one and subtracting. Now the formula right above us here is to take f of x sub n. So for this particular function, that would mean that I would take x sub n squared minus 2, right? F of x just means the original function. And in the denominator, I'll be evaluating the derivative at x sub n. So first, let's just go ahead and quickly calculate our derivative, 2 times x. And that would mean that in my denominator, I'll have 2 times x sub n. So x1, my initial estimate is 1. That was given to me. In order to calculate our next estimate, I'll take that value and I'll plug it in as my variable. So here I would get 1 minus 1 squared minus 2 all over 2 times 1. Right? Everywhere that I had an x sub n, I popped in the previous value, which was 1. If I go ahead and calculate this out, I'll get 1 minus a negative 1/2, which is equal to 3/2, or 1.5. Right? We can tell by looking at this that the actual answer should be the square root of 2. And the square root of 2 is roughly equal to 1.414, and so I am getting closer than my previous estimate. Let's go ahead and do 3 iterations, meaning that we want to do this process 3 times and see how close we can get. So my next estimate, I would go ahead and use the previous answer as the variable in my formula. So this time I'll have 1.5 minus 1.5 squared minus 2 over 2 times 1.5. And I could go ahead and type that all into my calculator, and you'll get 1.4167. So I'm kind of pretending here that I typed it. I just did it ahead of time and put that number in. But you could go ahead and double check. Pause and take a minute to make sure you get the same answer. Again, if my answer is supposed to be the square root of 2, look how close we're getting with just the second estimate here. And then finally, it did ask for 3 iterations. We would be taking that value, 1.4167, and plugging it in as the variable into each of our subsequent calculations. So it would look like this if I was writing it all out or doing it by hand or even with a scientific calculator. When you go ahead and plug that in, you get 1.4142, and knowing that the actual zero should be at the square root of 2, that's really, really, really close to where we should be. I do want to take a second and show you a really cool shortcut. You would need a calculator anyway in order to do this problem, right? I would never ask you guys to be plugging in 1.5 squared, let alone a 4-digit decimal, square it, and then do all this division, right? You would have to have minimum a scientific, and usually in here we use graphers. So there's a really neat trick in order to calculate these values. You can go ahead, and once you have your setup, you can go ahead and use the graphing calculator to do all the legwork for you. So the trick is, let's see if I can move this up. We're going to go ahead into y. I'll clear out whatever was there, and I'm going to type in my equation that I've set up. Now your calculator can't put in x sub n. It really doesn't care what your variable is called. So here we're just going to call it x minus. If you have the feature with the fraction, it's so helpful here. It really makes it a lot easier to set it up. So now we're going to have our variable squared minus 2. And then remember, it was over the derivative, so 2 times x was my derivative. So essentially, right, I have x minus, and then on the top I have my original function, and I'm dividing by the function evaluated at the derivative. Let's see. So we want to go ahead and access our table. But I want to be able to ask it for specific values. So if you remember, we can go right above window, table setting, so second window, and I'm going to set it so that the independent variable is on ask. That way I can choose what it's going to show in its tables. So second table, now I have nothing here, but we can go ahead and we can use the table feature in our function to calculate all the other values. When I plug in 1 to my equation, I get 3/2 or 1.5. Looks like mine is set to fractions. When I plug in 3/2, right, I can compute the 1.4167, and then I'll just use that last value, right, and it'll generate for me the last one, 1.4142. So it's a really quick way. When you're doing your homework, when you're taking a quiz or a test, you would want to show this initial step right here where you've set it up, and you would want to show sort of just x1 equals, x2 equals, and just give the answer. So you don't have to show this part for me where you're actually calculating. You would just write x2 equals 1.5, x3 equals 1.4167, and so on. You can use your calculator to shortcut the process. Let's see if we can get one more in here really quick then, just using our process. So let's see. Here we have a cubic function. This one might be harder to factor on our own. What are we going to need? We're going to need to set up our equation. So x sub n minus, and for this function, right, I would want my original function on top, so x sub n cubed plus x sub n squared minus x sub n plus 1. And then underneath, I'll take the derivative. So here, 3 times 2 makes 6, x sub n squared. I'll have plus 2 x sub n and minus 1. The difference between this one and the previous one is that they haven't given me a best estimate. So let's use our graphing calculator, since we're assuming that we have one, to just get an eyeball to get an estimate of what the zero should be. 2x to the third plus x squared, whoops, minus x and plus 1. And when I look at the graph, mine is set to some sort of trig function. Let's go back and press zoom 6 to get back to the standard form. I can go ahead and I can see, well, it looks like it goes through around -1. I don't want to ask it for the 0. Okay, I want to practice the method, the Newton's method process. So it looks like it's crossing right around -1. And so I will let x1 equal -1. I'm going to have to go back and clear this out and enter in my setup, right? I'll have x minus alpha y equals, we'll set up that fraction, and I'll type my original function at the top. So let's see, plus x squared minus x plus 1, and my derivative on the bottom. So 6x squared plus 2x and minus 1. And my table should already be set up. I can go ahead, let's just delete these old ones from the previous function, and I'll go ahead and I'll put in my first approximation. Right? When we looked, we thought maybe -1 was the solution, and it's telling me that when I plug -1 into this whole formula for Newton's method, I get -4/3. And so I would use that value and plug it back into the same formula. So the third iteration is giving me -1.243, and I can go ahead and do it again. And it gave me -1.234. And let's see, it wants me to be off by not very many decimal places. So let's just go until we get the same thing twice in a row. And look, this time with my entry, I got the exact same thing that I got beforehand. And so my approximation will be at -1.234. If you don't like the table feature, maybe that it doesn't go out as many decimal places as you need it, you could also use the graph. To give it a second here. And you could use second calculate, and you could use the value feature. So if I plug in -1, this will give me a few more decimal places when I'm copying them down. So I could use all the decimal places in order to get a more accurate solution.